Good afternoon. Thank you for being here with me. I am extremely happy to be here with you all again. It's been, well, it feels great for the first time in about a year and a half to actually talk to people and see them instead of talking to a camera and getting nothing back. But I'm quite sure that this is something that you have heard about 100 times today already. And that's not the point of our conversation today. Our conversation today is going to be about, well, connecting API-first design with API-first development. And I'm maybe getting a bit ahead of myself, but often, in my experience, we notice that we come up with a great API design when we start some project or some service or whatever. And as time progresses and development goes on, the implementation starts to drift away from the design, or the design starts to drift away from the implementation, depending on your point of view. And what I wanted, what my team wanted, was a way to try to ensure that the implementation and the design did not drift away, so we would not have to answer, those annoying calls and emails asking, why doesn't your service behave as advertised? And you also know what they say about opinions. They are like belly buttons. Everybody has got one, and this is mine. And who am I? My name is Vasco Veloso. You have seen that already. I've been doing software for a couple of decades now. Not that it means that I know a lot about it. It just means that I've been doing it for a long time. And I am, well, I'm not originally from Central Europe, as you can see, and I'm still here around developing software. Now, what is API-first design? For those who are not so familiar with the term, what is the whole idea behind it before we get to the actual development and implementation part? Well, the idea with API-first design is that the interface comes first. So before you actually start writing production code, you define your interface, you define your API. What's the advantage of starting with the API? Now, on one hand, when you are doing API design, you are thinking about data flows. You are looking at the way how data flows from one component to the other. And while doing that, you may end up discovering that your earlier assumptions about the dependencies for the new service you are creating were correct, and in that case, congratulations. And in many cases, you discover that those assumptions were not entirely correct, because now you see that you want some little bit of data coming out of this new service that needs to be fetched from some other dependency, and congratulations, you just discovered a new dependency in the process. Now, because you're looking at data, you can also challenge the need for some specific piece of information to be flying over the wire in that transaction. Because, well, we are becoming increasingly concerned with subjects such as compliance and privacy, and, well, let's not forget the usual concern, which is bandwidth and latency. The less bytes you get on the wire, the faster your request completes. So you can always challenge, do we need that right now? And there was a keynote after lunch today, and one of the points was exactly asking this question, do we need this right now? Is it really necessary? That is something that you can challenge while designing the interface. And because at that point you have not written any production code, then there is no concern about, well, but it already works that way. No, it's not there yet, right? Now, I mentioned security. And when we are looking at an API, that also means that you can discuss security over that API. Because you're looking at data, you can discuss authentication, you can discuss authorization, and you can discuss also what requirements, if any, you have over that data. So threat analysis also becomes a great advantage. And when you get an API, a specification in front of you, then you know exactly what you're talking about. However, this is all nice and beautiful, but we all know that life as a developer slash architect slash designer is not always nice and beautiful. Depending on the team and the organization you work with, you may have a dozen of options for collaborating. You may exchange interface specifications by email, or in a Word document, or in Confluence, or, God forbid, in Jira, or in any other means. And that is fine, as long as that's the way how your team communicates. Nothing wrong with that. There is one disadvantage, though. Those means of communication are not technical in nature. A Word document is, Word was designed for novelists, let's be honest. It's a word processing tool. It doesn't have any connection to the software development world, just to give an example. So while all those tools are fine to exchange opinions, when it comes to the technical part of it, and we're talking about API specifications, then they are a bit lacking. So you probably already went through that scenario. You exchange emails, exchange documents, exchange notes, then you come to an agreement, and now you have 4 different documents, and you need to translate that into something that can be actually implemented. So why not actually use a tool that can be technical? How we are going to do that? Let's take a look at that in a moment. And also remember that the other side of the problematic coin is that there are specifications that actually don't have that much value because they became out of date. Because you look at the specification and it says that, okay, so parameter ID is an integer. Okay, that's an integer. Fine. And what does ID mean? It just says ID. What does it mean? And you need to ask someone, what is this ID? So there are no examples. There are no descriptions. There are many specifications out there that actually work like this, like my favorite pieces of documentation in which you read the field ID and the description is an identifier. Thank you. That made my day. Another problem, even if the specification was indeed well done and well written from the beginning, is that, as I said in a couple of slides back, it became outdated. And it no longer matches the actual behavior of the service, and that leads to surprises. Someone said a couple of days ago that a good API should follow the principle of least astonishment. So if you look at it, you shouldn't be surprised, and you also should not be surprised if the service does not behave correctly. So we have lots of problems. And how can we find a way to overcome those problems? Well, I am suggesting not only API-first design, but also API-first development. At this point, we have already created an API specification. And that specification is written under the form of a API 2.0, also known as Swagger, or an API 3. An Open API 3.0 document. And these standards, they describe a format for a document in plain text that specifies the endpoints that you have available in your API. And this is about the point in which we are moving towards a specific scenario, which is an API that is meant to be served over HTTP. REST, RPC, does not matter. A Swagger document is particularly built for these scenarios. Now, why am I advocating for a Swagger, or more generically speaking, Open API, which version you use depends on the tool that you have available? The fact is it's plain text. And because it is plain text, you can easily version it. Because it is plain text, then you can use pretty much any tool that you want to edit it, and you can use it during your refinements. So when you are sitting with your team, your domain architect, or your whatever other stakeholder, you can just edit the document and make those changes as you go. And whatever notes you had, then they are already in the specification. So no need for an intermediate format. The other advantage is that there is tooling that allows you to convert the specification into other, more readable formats. So if you need to describe your API to a person who is not excessively technical, to some business stakeholder, for example, and you don't want to go into big technical details, you can convert it, for example, to HTML and go to that person and show them. They may not understand why the endpoint has all those, why is it named as it is, or what is a get, or what is a put. But you can show them the list of attributes with the descriptions and say, okay, so this is the data that we are going to be exchanging. And this is going to, what is going to be happening when this operation is called. Because if you're talking to a business person about a sale, an order, they know what an order is, and they can easily see if the data is according to their expectations. And then finally, the connection to development. You can use the Swagger file, you can use that specification to actually generate code. Now, in this slide, I used Java as a target language, as an example, but there are other generators that can generate other languages. But well, this is the Netherlands Java users group, so Java, makes sense. And after you generate code into Java and you compile it, you get it into your pipeline, CI, CD, it just flows throughout your normal development cycle. That's not an issue. You may also ask, okay, what other benefits may I get from this? And this is the point in which we start talking about, for example, capabilities. If we look at one of the very well-known research companies that has been active in the past years and is now a Google department, the DORA research group, in their 2019 Accelerate State of DevOps report, they published a set of capabilities that they believe are important for any organization in behaving their DevOps capabilities. In my opinion, this approach actually ticks two of those boxes. So one of those boxes is about code maintainability, because we are generating code. So that means the code is going to be generated according to the same pattern everywhere, because, well, the generator does not have good and bad days and does not change the code style from Monday to Tuesday and from Tuesday to Wednesday. On the other hand, there is also another important aspect that I don't think that there is no time to cover it today, but it is automated testing. Because just like we can generate code from the specification, we can also use tooling to read the specification and generate requests against our service to check the service's behavior. So it is possible to verify if the server's responses comply to the specification or not. And so we avoid surprises during implementation, even though we have code being generated. There is always the possibility that we forgot something in the spec, and the tooling can actually catch that. Okay, but that was 2019. It is now 2021. What else can we say? Same research team, this time last year's report. Last year they focused on different things. And remember how I said a couple of slides back that the specification can also be used to talk to other stakeholders, and it is also a form of documentation? Well, it turns out that this same research group came to the conclusion that teams with a quality documentation are much more likely to have good practices, security practices, for example. And a specification for a service is also documentation. So it's part of the documentation for that service. It will also improve the team's performance in the long run. Well, if not only then because the consumers are not calling and asking for details, then that leaves us more time to actually get some work done. Now, that being said, in order for code generation to be useful, and in order for automated testing to be possible and provide relevant results, we still need to be careful. All inputs must be defined in the documentation. So the specification needs to be as complete as possible. If there are two features, for example, in the Swagger version that you are using, that you can use and that makes sense for your endpoint, then by all means use them. Make it as complete as possible. Your users will thank you. You will thank yourself because your code is more complete, and you will get better testing. And of course, that also means that we need to generate, again, that we need to generate the code from that specification. And we can not only generate the client code, so your consumers can use your specification to generate a little bit of their app that actually connects to your service, but you can also generate your server interface, which is also boilerplate code and saves you from having to maintain it. You just edit the specification, run your build, and voila, your server has been updated. If your new code is not compatible, you get a compile time error. Congratulations, you just verified that you need to make changes. So, advantages for this method. Your single source of truth is the API specification. There are no more 4-word documents, 2 Confluence pages, and 1 ticket that all have information about your service. Your code is always in sync with your specification because you are generating the code from the specification. Considering that you have followed the advice of having the specification complete, then not only you are generating code, but you can run automated tests. And of course, then you get lots of benefits from the framework that you are using as much as possible. What does this cycle look like in practice? Well, because no presentation about something that says design in the name is complete without some boxes and arrows. There you have the boxes and arrows. And the very first step is, of course, designing the API. You sit down with some people and you start discussing it. You write the specification as you go. Something is missing, you go back to that stage, you iterate, 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 you are happy, you generate the code. Mind you, this could be the code for your production service, or it could be the code for a quick prototype that you want to do just to try something out. Does not matter. The specification is the same. One possible way of generating that code is, for example, using the OpenAPI plugin for Maven, for example. Then you go through the normal development process, you implement everything, you test your business rules, the important stuff in your service, you do that. And then you get to the point in which you can use the specification to validate the implementation of your interface. Mind you, these are not functional tests. These are specification tests, which means that this tooling can, for example, Restler and schemathesis, they can generate requests and check that the responses match the specification. And that's the only purpose. These are not functional tests. Functional tests come according to your normal development process. You deploy, and you go back to the beginning, like any good agile and iterative process. Now, let's imagine that we have a Java service, or that we want to create a Java service using Spring, just to give you an idea of what is possible with an approach like this. And pro tip, we are going to look at some slides with code, so if you feel the need for a power nap, now is just about a perfect time, okay? All right. Anyway, so let's look at the specification. This is just a small part from a demonstration Swagger spec. And what you see there is that the Swagger spec says that there are two operations on one endpoint. Those operations behave differently. So one is a get, the other is a put. They provide and receive different kinds of data. And you can notice that they have references to some objects that are exchanged in that endpoint. Those objects are also defined on the same Swagger file. Now, small detail, especially on the greeting object. Notice that we are defining not only the name of the properties, so there is one property with the very original name of text. We are specifying its type. We are also specifying a regular pattern, which is actually not correct, and kudos to the person who figures out what it is without using an automated tool. Specifying the characters that are allowed in that field. It also defines a maximum length. And these are normally questions that you should also ask from a security point of view. So if you are accepting input from your user, then what is a valid input from your user? For example, how long should it be? Let's not allow our service to propagate erroneous information, and so on and so forth. There is an example. And the example is useful because code generation tools can actually generate tests using the examples. And we have something nice for our human fellows, and that is the description. A human looks at that, and hopefully the description is good enough for someone to understand. So we have written our Swagger spec. We are, let's say that we are using Maven. We are setting up our project. Now there's lots of text there. Well, because Maven is verbose, it's XML. You already know how that goes. But the point is that we can add a plugin to our build process. We can configure it. It will read our specification and will, if our specification is correct, it will generate some code. Now, what is the advantage of generating code based on a specification that actually specifies examples and sizes and limits? In the specific case of Spring MVC, an interface definition is going to be generated. And it will include lots of annotations that are good for humans, reading it, but are also good for, specifically in the case of Spring, bean validation. You will notice in this big mess of annotations that there is at least one over there, which is the valid annotation. And that means that we are asking the framework to actually check whether the object that's being passed is valid. Because the code is generated, then the constraints that we have defined in the specification are also included in the data object that is being created in Java. So now we have an exchange model in Java that matches the Swagger definition. Now, you may, of course, argue that you may need some additional validations that cannot be expressed in Swagger. That is possible. If you are using Spring MVC, like in this example, then you can extend that validation and add your own validations using the standard Spring mechanisms. What I am trying to demonstrate here is that there's a lot of boilerplate code that you don't need to write if you start with a specification that is already technically valid and can be connected to your development flow. From the moment that you generate this code, and this example will actually result in something that can be run right away, and by default you will get a prototype that will return an HTTP of code of not implemented, although this is configurable, is that you can quickly prototype your service. After you generate the code, you can create a controller implementation and you can return some stub data or anything that you want to speed up your prototyping phase. When you're happy, you either continue with that project or you throw it away, generate a new one, and you start writing production code. Now, more than once, I got the question. What if we just, flip that upside down? So what if, couldn't we just write the code and generate the specification later? Because you are saying, well, you want the code and the spec to be in sync, so why don't we do it the other way around? Well, that is possible, of course. And like I said at the beginning, opinions are like belly buttons. Everybody got one, and this is mine, and I'm happy to discuss it. And what I believe, if we flip the approach around, is that, well, so to generate specification from code, you need code to begin with. So all that boilerplate code, all those annotations that you saw being generated, yeah, you need to write them first. And then you need to run whatever tool you're using to create the Swagger spec. That means that the specification is no longer your single source of truth. Now it's your code. And the problem is that if you then decide to throw away your prototype to build some production-grade code, then either you are very selective with copy-paste or you need to start over again. Now, on top of that, it means that every iteration that you make with regards to the specification implies necessarily that your prototype must evolve. So you need to keep changing the code. Now, in my opinion, that's much more cumbersome than just editing a text file. Then, because at that point you are dealing with code, then it becomes a lot easier and a lot tempting to write code using techniques that employ data types or some data structures or some kind of validations. I'm thinking about, for example, polymorphic data types. Those cannot be easily represented in OpenAPI, especially version 2. Version 3 has some support for polymorphism. And generation tools, they don't always understand those concepts. So it is possible that you will end up with a specification that is not entirely accurate, and in some cases it's not even correct. And then the other consequence is that in the very beginning of the whole process, while you still haven't defined your interface, you are thinking in code, you are thinking in implementation already, when you should be discussing the API and data and dependencies. Well, in some cases, then it may turn into an argument about which technique is best for developing. Then, well, we are humans. And because we are humans, then we will forget things. Of course, the argument can also be made that, yeah, but if you are writing the Swagger API, then you will also forget to add things there. True, you will. You will. But because you are writing code and you can add those validations by hand, it is possible then that because you forgot one annotation, but you have that validation in your code, your unit test passes, you're happy, but you forgot to add the annotation, and now you don't have that in the specification. And it is incomplete. So basically, the specification is losing value. Of course, now what? Which way to go? As always, with any good design decision, it depends. Do you have a disciplined team who never forgets anything? They really like prototyping. They don't mind copying information from emails or whatever. And you want to go prototype first? By all means, go ahead. Just don't forget to use the generated specification then to run automated tests against your API to make sure that they are still in sync with each other. My opinion, however, stands that it is easier to write the specification first and then generate the code and generate the tests. And then every time you need to make a change to the interface, then everybody becomes very much aware that the specification is changing, and that may have impact in consumers, especially because depending on your tooling, you may be required to publish that specification somewhere. And specifications have version numbers, and then you need to version them correctly. So, my main takeaways for today are that an API-first design and development process should be divided into basically 3 steps. First, you build, and by building, we are talking about specification, so you build the Open API first, and then after everything is described as detailed as possible in your Open API file, you generate the code. You generate code, you generate client code for your consumers if you want, or they generate them themselves, and you can generate tests that are going to validate whether your service is behaving correctly or not. And then finally, on the implementation phase, you extend the generated interfaces, because our example was looking at Spring MVC, and it will generate interfaces in code. And you extend them with the real controllers. You connect that to your business service. At the end, you have a service that can be verified automatically, and you are absolutely sure that your implementation matches your specification. I did not want to take much of your time. If you have questions or comments, we can discuss them right now. If not, then I'm quite sure that in a few minutes, there will be some drinks waiting for us outside. Yes, please.
Short question in that case.
Yeah.
Is it common practice to, if you make specification of a model, to use that specification in multiple applications? Or is that...
You mean, okay, so the question was whether it is a good practice if you specify a model to use the same specification in multiple applications. Do you mean that as a server application or as a client application?
No, I mean, if you make a data model, for example, you can use it in any application, I think.
Yeah.
Regardless if it's a server or a client.
Yeah.
Yeah. Can you reuse that model for applications?
Okay, so...
You have to also use multiple specifications in one application, but I don't know if it's possible.
Okay. Okay. So just to clarify, the question was related specifically to the data model and reusability of the data model that is generated from the specification in multiple applications. Okay. So the code generation from a specification can include only the exchange model. It is possible. So you can technically generate only the exchange model, and based on that, generate some sort of shared library that you can share between applications. An example of that, although it's not direct, is when you generate the server interface, then you generate that interface we were looking at previously, and it will also generate the exchange model. If you use the generator as a tool for the client application, then depending on the generator you use, you may end up generating only the datum, the exchange model itself. So you can do that, definitely. Normally the connection between those two applications, or at least the recommended connection between those two applications, would be a client-server connection. However, depending on your specific setup, if you have, for example, one API whose implementation is divided in multiple services, so each service serves one part of the API, then I don't see any reason why you could not share the model between them. Of course, that the usual advice regarding sharing data models is that, well, unless those services are extremely connected, they will become extremely coupled. And the usual advice about sharing kernels applies. So the shared kernel, as you probably know, is a pattern, especially from domain-driven design, and it's a bit of an anti-pattern, but it is something that you definitely can do. Yes. So if there are no further questions. I will not take your time any further, and enjoy the drinks. Thank you.